this is the Assistant Professor of Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the MOSFET operating modes. What are the operating modes we have and how it is going to be operated. We are going to see about it. Here the operating modes we have is that cutoff region, active region and a saturation region. We have three types of region. One is cutoff region and another one is active region or linear region or an ohmic region it is called as. Okay, and third one is saturation region. Cutoff region is that where no current is found, where the supply voltage is zero, where no voltage is given, there will have a minimum amount of voltage which is less than the threshold voltage. Okay, when the gate source voltage is very minimum than the threshold voltage, will have a small supply voltage, will have a minimum voltage called minimum voltage in the cutoff region. When no supply voltage is given, will form a very minimum amount of current called in the cutoff region. And next is the active region, when the gate voltage is applied and we have a supply voltage and we get a minimum amount of current between the gate and source and the drain region, which is greater than the threshold voltage. That is called the active region. And whereas the current and the voltage gets increased during this region. Then what is saturation region? It gets saturated where the higher amount of input, that is higher amount of current or voltage is given to the gate source voltage. Okay, where the drain source current, the voltage between the drain and the source is larger than or equal to the gate source voltage and the threshold voltage. Okay, there forms a region called saturation region where a constant current is developed. A constant current is developed. This channel is also called as pinch off at drain. Pinch off voltage, where it reaches a very saturation point. That is called pinch off voltage, where we have cutoff region, active region and a saturation region. In cutoff region, where ID is equal to 0, VGS is very less than VTH, that is threshold voltage, no channel is formed. That is, we don't have any channel. We have two types of mode here, that depletion mode and enhancement mode. And depletion channel and enhancement channel, will have a small channel in between the N plus diffusions once when the current flow increases. In cutoff region, we don't have any drain current, ID will be of 0, so no channel will be formed. In the ohmic or linear region condition, where VDS, that is drain source voltage, is less than VGS, which is a small amount of energy, the supply is given. A variable resistance, a small amount of resistance is found. No pinched off, where we don't have high current or voltage in that region. Okay. Next, we are moving on to the saturation region, where VDS is greater than or equal to VGS minus VTH, where drain source voltage will be very higher than, which is equal to the gate source voltage, where the current will be very constant and a pinch off at the drain, a pinch off region is formed, where saturation constant current is formed. Characteristics of MOSFET. Output characteristics. How does this characteristics form? This is plotted between the ID, that is drain current, and the drain source voltage. Between the drain current and the drain source voltage. How does this curve forms is that difference of VGS values. VGS, that is how the gate source voltage will be varying according to that. This curve, that is We can see the curves, right? Increasing the current and voltage will be of a constant. This curve will be formed once the gate source voltage is increasing accordingly. Okay. In this, as this gate source voltage increases, the waveform generated. In this waveform, we can find these regions: cutoff region, ohmic region, saturation region, and a breakdown also. The pinch off, as I told you, pinch off region is there, ohmic region is there. Ohmic region is the region where this gradually the increasing part of the current is called the ohmic region. Okay, saturation region is that where the entire voltage gets saturated. It will be in a constant, where we have the constant current flow. And pinch off is the part where it gets saturated. Pinch off is a point where this current gets saturated. That point is called a pinch off voltage. Okay. Transport characteristics is plotted between ID and VDS, where ID is equal to K into constant K into VGS minus VTH the whole square. K is the process transconductance parameter. It is a transconductance parameter. MOSFET amplifier configuration. How does this MOSFET amplifier configuration has been done? MOSFET is a common source amplifier. We can use this transistor to develop a amplifier. It will be working as an amplifier too. Okay. This structure, see in this diagram, we can see that this is a complex structure and it has been replaced. It has been given a equivalent structure with the help of H parameters. Okay, by using the H parameter, this equivalent circuit has been given in the right side. The common source amplifier here it has high gain and 180 degree phase inversion. Okay, it has high gain and 180 degree phase inversion has been done. Biasing components, that is RG, RD and RS, that is R resistance gate, resistance drain and resistance source. Input impedance, gate terminal which is equivalent to no DC current. When we get the high input impedance is as when there is no DC current, the gate terminal will be fine. Okay. Transconductance is GM is equal to 2 into ID divided by VGS minus VTH. GM is equal to 2 ID divided by VGS minus VTH. These are the how this MOSFET is transformed into a common source amplifier which gives an 180 degree phase inversion where the input to output will be of very high. These are the components and these are the working how the MOSFET is transformed into an amplifier application. Thank you.